Thank you, Professor. Good morning, ladies and gentlemen. Quite an honor to be here to do the introductory lecture. And I want to start by talking about digital dentistry. Digital dentistry is the use of digital and computer technologies in dentistry. And some examples are digital x-rays. These use sensors instead of film to capture and store images of the teeth and surrounding tissues. Another example is CAD/CAM systems. These computer-aided design and manufacturing systems can be used to create custom dental restorations such as crowns. Dental imaging software. This software allows dentists to create 3D models of the teeth and surrounding structures. And dental practice management software. This software helps dentists to manage their practice, including scheduling, appointments, tracking patient records, and billing. But you know what? I actually know nothing about digital dentistry. And therefore, I used artificial intelligence to create this talk. So everything I presented was generated by ChatGPT and by DALL-E. I simply gave it the prompt, digital dentistry, and this is what it created for me. I think that we live in extremely exciting times. I've worked in artificial intelligence for many decades, and what has happened over the last half year is a quantum leap in this science, but also a quantum leap for society. So I want to take you a little bit through the foundations of digitization and of artificial intelligence. I also wanted to introduce you into the metaverse. But what happened is I had to give the talk, the title of the talk, to the organizers about 5-6 months ago. 5-6 months ago, the metaverse was still a big thing. It is no longer. And therefore, I'm going to change the title of my talk to Digitization, Artificial Intelligence, and something GPT. So let me go into some more detail. The professor already introduced my background. So Wido Menhardt, I studied physics here in Vienna at the Technical University. And then I did my PhD, my doctorate in artificial intelligence in Hamburg in 1990. So in the introduction this morning, somebody said that artificial intelligence came along in 2010. But I can tell you artificial intelligence has been around for a lot longer. When I talk to young people, they think artificial intelligence was invented 6 or 7 years ago. My PhD was 30 years ago. I've worked in a bunch of startups and in a bunch of large companies. In terms of startups, maybe some highlights. In 1994, at Sedara, we introduced the first image-guided surgery device that was approved by the FDA. This kind of technology is used in dentistry today as well for implant planning. And another startup I was involved in, or which I led actually, was Miramedica, which was an artificial intelligence technology for mammography screening, so for imaging, identifying densities and microcalcifications automatically. This was approved by the FDA in 2003. So the FDA has also been involved in artificial intelligence for more than 20 years. I also worked for large companies like Philips, where I led their radiology informatics division, their PACS division. Beckman Coulter, a diagnostic company where I was responsible for clinical informatics, the cloud, data analytics, stuff like that. And my last corporate assignment was with Siemens Healthineers, where I was the general manager for the digital health division, which included products like radiology AI, I will talk about that, telehealth, and CDS, computerized decision support for cancer diagnostics. I've lived all over the world, the last 25 years in California, but also in Asia and several countries in Europe. And I'll start by talking about digitization, digitalization, digital transformation. There are many words that start with digit, and I want to maybe do some definition of the terms. So first, I'll talk about digitization. And I'd like to introduce a good friend of mine, metaphorically speaking, Dr. Shannon, who is called the father of the information age by some people, and he will appear several times in my talk. So he thought about how to take continuous natural signals and represent them in a computer. And the The challenge is, of course, that natural signals are continuous, except for quantum theory, of course, but in a computer you can't represent the continuous signal because a computer has limited address spaces. You have to chop the signal into pieces in order to represent it. And the question is, how can you digitize, so turn into computer form, a signal in such a way that it still makes sense once it's in the computer? So let's take an example. Let's take this sine wave, and let's see how many data points do we need to represent that in a way that is useful in a digital computer. And I have this nerd alert here. So the nerd alert means I'm going to talk a little bit about mathematics, about the inner workings of computer technology. So if you're not ready for that, you can now look at your phones, do your email until the nerd alert sign goes away again. So this signal, let's try to sample it a couple of times and see what happens. Let's sample it 6 times. So 6 measurements of this signal will represent that in a computer. And as you can see, the resulting signal does not look like the input sine wave. So 6 samples here are not enough. Let's sample it twice as often, and it already approaches the form of the signal that was input. But for example, for medical diagnostics or therapy decisions, this may not be good enough. So we'll sample it more often. And now it already looks like a sine wave. And the key that Shannon provided to science and to the digital world was to create a theorem which allows you to look at the original signal and determine how many data points you need. In dentistry, this is quite relevant because if you look at your x-rays, you need to make sure that you have the right resolution. Otherwise, details that may be important to your diagnostics will be lost. Image resolution is a key element, and it's not as simple as saying I need to see structures that are 1 millimeter wide, for example, and therefore my pixels have to be 1 millimeter wide. It's more complex than that, and that's what Shannon provided as innovation to our field. So digitization is sampling natural phenomena and representing them in a computer in bits and bytes. Then I want to talk about digitalization and digital transformation. And here I'll use some examples from consumer technology. So if you remember, some of you maybe remember VHS tapes. VHS tapes are continuous recording of a video signal. And then at some point DVDs came along and the signal had to be digitized. So what we just talked about, converting the movie into bits and bytes, happened, and you have a DVD. Similar if you have a document, this is my birth certificate, I can put it on a scanner, I get a PDF, it's digitized. But nothing really happened in terms of change to processes or workflow yet. The DVDs are still on a shelf, just like the VHS tapes. Next step is digitalization. This is now making these digital forms available for storage, for transfer, for access. So you put them, for example, on a media server, or in the case of documents, the government may put them in the cloud or in a data center. They're available, but again, nothing big has changed yet. Then comes the step of digital transformation. This is when people come around and decide to change workflows or business models by using digital foundations. For example, Netflix. Netflix decided to start to stream movies on multiple screens, in multiple locations, and they were also able to change the business model into a subscription business model, which wasn't really possible before. In a similar way, the government has decided to make certain workflows with documents available on a mobile app, where you don't have to go into a government office anymore, but you can do your applications for permits on a mobile phone. So these are the 3 levels. Digitization, turn it into bits and bytes. Digitalization, make it accessible. Digital transformation, doing something different that wasn't possible before the digital world. In terms of healthcare, it actually turns out that the speed of digital transformation has been very, very slow. Here's 2 statistics, and you can see that healthcare is at the very bottom of the digitalization journey. If you think about your own life as a consumer, digitalization actually has happened pretty quickly. We've been using Netflix for almost 2 decades now. I don't like to go shopping, but on Amazon it's actually quite convenient. So that transformation has happened quickly. In the medical field, it has been slow. The reasons for that you probably can guess at. Some of them are concerns about patient privacy, although in the banking world, they've solved that a long time ago. It may also have to do with very complex billing mechanisms and the resistance to change there. And just in general, medical workflows, as you very well know, are pretty arcane and have not undergone a lot of optimization, such as in the corporate world. So in dentistry, as I said, I know nothing about dentistry or digital dentistry, but my feeling is that the speed of digital transformation in dentistry is actually faster than in the rest of the medical field. My background is mostly in radiology, and some of the examples that I've seen, just checking the contrast here, some of the examples that I found are automated interpretation of dental x-rays, identifying caries, just like in mammography I talked about earlier, which allows an increase in sensitivity of the dentist combined with the system as opposed to the dentist alone. Another example is the creation of crowns and implants right in the doctor's office with intraoral imaging and in-office CAD/CAM technology. Another example is interactive image-guided implant positioning. And finally, of course, practice management software, which allows the optimization of workflows and also with a mobile app, an increase in patient satisfaction. So I'm a bit embarrassed to talk about this, of course, because I don't know about digital dentistry, and you'll hear a lot more about that in the rest of the conference. Now let me talk about the second topic in my talk, artificial intelligence. And artificial intelligence actually has been around for a very, very long time. Here's a timeline that I found. It starts somewhere in the Middle Ages, but there are also people that locate the beginnings of artificial intelligence, the beginnings of the desire to motorize or mechanize human thought with Greek philosophers. For the purposes of this talk, I want to highlight a couple of dates. One of them is 1950, which was when Alan Turing defined the Turing test, and I'll talk about that. The next one is 1955, 1965, when the term artificial intelligence was defined as the term for the field. Then 1965 or 1966, ELIZA, a chatbot that mimics a psychotherapist. Then another date that's probably a highlight is 2011, when IBM Watson beat the leading contestant at Jeopardy. Jeopardy is a famous TV game show in the US, which is considered quite difficult. And IBM Watson's computer was able to beat the human contestants. And then the other date maybe to highlight is 2016, when AlphaGo beat a leading Go player, which was a feat that was considered very, very difficult. This chart, of course, now needs to be extended to something like November 2022, when ChatGPT came on the scene. But I couldn't find a chart that has that in it. So let's talk about a couple of these waypoints in artificial intelligence. And the first one is Alan Turing. And some of you may be familiar with the name because of the Netflix movie The Imitation Game with Benedict Cumberbatch in the leading role. And what happened there was he built an electromechanical computing device to beat the Enigma. Enigma was the encryption device for German submarines, and the Brits were listening into that and wanted to crack the code, which they did, not only with this device, but also with some tricks, as you probably know from the movie. But Alan Turing is important to the artificial intelligence field because of the Turing test. And the way the Turing test works is, imagine you sit in a room, you're the interrogator or the tester, you sit in a room, you have a computer terminal in front of you, and you chat with an entity in another room. In the other room, you don't know whether it's a human being or a computer. And what Alan Turing said, the test is successful for the machine, so the machine is considered to be artificially intelligent if the interrogator cannot tell whether the entity on the other side is a computer or a human being. So that Turing test has survived the test of time since for the last 60, 70 years. But ChatGPT actually puts it a bit in question, because at first, if you don't know about it, ChatGPT will certainly mimic a human interactor, and you won't be able to tell, in particular if you don't know how to trick ChatGPT. So I said it's exciting times if the Turing test is tested. And I think chatbots like ChatGPT will be implemented for customer service applications online pretty quickly. And in those cases, you simply won't be able to tell whether it's a human or the computer. So the Turing test, very important, and it will probably have to change because ChatGPT, getting a bit philosophical, doesn't think, doesn't self-reflect, doesn't create new things actually. So it's certainly not generally artificial intelligence, but how to test it remains difficult. The next milestone is the definition of the term artificial intelligence. This happened apparently at a workshop where some famous artificial intelligence researchers participated. One is again our friend Dr. Shannon, another is John McCarthy of Stanford University, and another one is Marvin Minsky of the MIT lab. These names appear again and again in artificial intelligence. And I decided to put a quote here by Marvin Minsky, that's actually 1970, 15 years later. But he said, in from 3 to 8 years, we will have a machine with the general intelligence of an average human being. And I think we can all agree this didn't happen. And it's actually quite interesting that in the artificial intelligence field, very often people make predictions about the next 5, 10 years that actually don't happen. And even today, if you listen to the leaders of OpenAI, the company that created ChatGPT, they make predictions like that as well. My prediction is that those predictions will be wrong. In 1957, also a very important milestone, Frank Rosenblatt came up with the perceptron neural network. And his idea was an artificial intelligence should maybe mimic what happens in the human brain. And we know that the human brain consists of neurons and synapses that are connected and complex things happen, but intelligence emerges from it. So he thought, let me simulate a neuron in the computer, then put a whole bunch of them together, and maybe with that, I can create intelligence. And the artificial neuron simply consists of a couple of inputs, the neuron itself, which sums up the inputs, applies some transfer function, and it actually gets quite complicated, but in principle that's it. And then it has an output that feeds into other neurons. So that's the principle of an artificial neuron, and it will come back in just a couple minutes. Then I want to introduce ELIZA. ELIZA was a chatbot in 1966, and it was created maybe as a bit of a joke, but also, I think, has some relevance to the development of the field. So ELIZA tries to mimic a psychotherapist. I'm just going to read a couple of the interactions here. So ELIZA says, how do you do? Please tell me your problem, which a human psychotherapist would probably start a conversation with as well. And you say, the patient says, I'm unhappy. How do you feel about being unhappy? That's also something a human psychotherapist might say. I need some help, that much is certain, etc., etc., etc. And you can go online. I put the link here, but you can just Google it. There are a couple of implementations of ELIZA online. And you'll see that the first couple of interactions with ELIZA are actually quite human. And then pretty soon it starts to deteriorate. But what you have to consider is that this was written in 1966, a long time before ChatGPT. The code, I've looked at the code, is actually very simple, very amusing. Then people had developed these neurons, but the computing performance in the 1970s and 1980s, 1990s was not sufficient to actually create a whole lot of neurons and train them in a computer. It just wasn't possible. So in the 1980s, artificial intelligence turned to trying to mimic human intelligence at the logic level. So they essentially thought, human expertise is a bunch of rules, if, then, else, and let's simply encode human knowledge as if, then rules. So you create a bunch of facts, you have some rules. If this fact is true and that fact is true, another fact is obviously also true, and with that, you create conclusions. It actually introduced a new job, the job of the knowledge engineer, and the knowledge engineer would go talk to an expert, extract all their knowledge into a bunch of rules, and then implement that in an expert system. A famous expert system, you can look it up, is Mycin, which diagnoses blood infectious diseases. And an example rule is shown here on this slide. You can look it up online. Expert systems still exist in certain limited domains, but I think we can all agree that intuitively, if-then rules are insufficient to model human intelligence. Here's another nerd alert, because I want to show you how a neural network works. And this actually will introduce some math, some calculations. And therefore, this is also the time, if you're not interested, to look at your mobile phone, do your email, and I'll tell you when the nerd alert is over. But essentially, it works based on what Rosenblatt introduced in 1957, and it's the foundation of all the AI that you see today, so quite interesting. What I want to do is create a neural network that identifies sharks. And I'm going to do that based on very few sensors. Just one sensor which says, does the animal live in water? And another sensor that says, does the animal have legs? And obviously, I'll also reduce the domain of available animals, hippopotamus, shark, horse, and snakes that live on land. So I want to have a neural network that, based on these inputs, determines whether it's a shark. So if the animal lives in water, it's 1. If it has no legs, it's 0. I want shark. I want 1. If the animal lives in water, 1. Has legs, 1. I want it to say it's not a shark because it's a hippopotamus. So we'll create a neural network for this, and we'll train it. Very simple neural network consisting of 5 neurons. 2 neurons that are connected to the sensors to determine whether the animal is in water, lives in water, and has legs. And 1 neuron at the output which says whether it's a shark or not, 0 or 1. And then 2 what's called hidden neurons. And then all these neurons are connected with synapses. So when it's a shark, water is 1, legs are 0. And on the output, I have shark, 1. If it's a hippopotamus, I have water 1, legs 1. I want it to say 0, not a shark. So neural networks consist of input layers, which are for the sensors, output layers, which are the results, and hidden layers. In this case, only 1 layer with 2 neurons. And then the synapses all have weights. The weights correspond essentially to the conductivity of synapses in the brain. The math for neural networks, very complicated. If you want to calculate the activation level of hidden layer neuron number 1, H1, you simply take input 1 times weight 1 plus input 2 times weight 2, and that's the result. Not very complicated. And in this neural network, there's only 3 calculations that you have to do to calculate the output. So simple math. In order to start to determine the weights, train the network, we have to initialize the weights, and we'll just do that in a random fashion. So these numbers that you see as weights are completely random. And let's start to train the network by applying shark to it. So shark lives in water, 1, has no legs, 0. We have the weights, we have the math, let's do the calculation. Well, the first calculation tells us that it's a shark with 0.03% or whatever you want to say. So that's certainly not 1. It's a large error. Large error is 0.97. So what do we do with this error? Now we introduce the most important formula for neural network training, which is backpropagation. You take that error, and with some math, which I won't get into here, you start to adjust the weight in a guided fashion, the weights in a guided fashion. Backpropagation, by the way, is, if you guys know what cone beam CT is, the reconstruction algorithms for cone beam CT, some of them use the same principle of backpropagation. So now we've adjusted the weights, and we do the calculation again. 0.04 is the result. So our error is 0.96. This is going pretty slowly. And that's true for neural network learning. That's why it takes such a long time and why it takes so many computers to train neural networks, because it's iterative and it requires many iterations. So if we let this run to the end, we get to a final configuration of the network which gives us sharp 0.87, so we round that up, it's 1. So this is the trained neural network. And I think we can stop the nerd alert. So if you were doing your email, please pay attention again. The innovation that happened at the beginning of the 2010s was the introduction of deep learning. And what that does, it takes that neural network, the perceptron, and just scales it up significantly. Many hidden layers, very complex internal connection structures, and that led to a revolution in AI, which allowed, for example, image recognition, speech recognition, all the stuff that you've seen even before ChatGPT. To give you a sense of scale, ChatGPT 4, I read somewhere, I'm not sure whether it's true, but has 100 billion neurons and 100 trillion connections. So it's completely different than the perceptron. And since you saw how long it takes to train that, you can imagine how expensive it is to train ChatGPT, for example. Deep learning. So I've spent most of my career in radiology AI, so I want to give you a couple of examples in radiology. And I know there are examples in dentistry as well. At the left, you see an example of a AI that segments, identifies about 50 organs, structures in a human torso based on MRI imaging in preparation of radiotherapy. In radiotherapy, it's critical to avoid certain organs. So before radiotherapy, conformant radiotherapy is applied, usually a technologist will go through the images and do that manual segmentation of the organs. That takes a half an hour or an hour or something like that. The AI can do that in minutes. Example at the top right, chest CT, 300-400 slices. The radiologist has to go through those, identify any nodules that might be there, identify them, measure them, classify them, put them in a table, compare them to previous imaging and so on. Takes a long time. AI can do it in a couple of minutes. And at the bottom bottom right, mammography screening. This is actually a device that's been around for about 20 years. In mammography screening, radiologists have to go through many normals. They'll see 80 normals before they see a case that might have some suspicion, and they have to see 99 cases or something before they see a malignant case. So it's repetitive, and mistakes are made. So with AI, the sensitivity of a radiologist will be increased from something like 80% to something like 90% for the radiologist with this technology. Since we're in Vienna, I also want to highlight at least 2 companies that are working in radiology AI out of Vienna. One is Image Biopsy Lab. They have decided to focus on MSK. Same pattern. When you do an X-ray of your knees, your hips, your spine, the radiologist and or the orthopedic surgeon has to use rulers and angle measurements and distant measurements, and they spend a lot of time to characterize the case in order to decide what action to take. AI can do it in a couple of seconds. And another example is Context Flow, which is a spin-out of the Medical University of Vienna. They have created technology to identify lung disease, nodules, but also other lung disease, and then provides the radiologist with some technology to look at the details of the presentation of the disease and help making therapy decisions. So that's radiology AI. Introducing Geoffrey Hinton. Geoffrey Hinton is the father of deep learning. Some call him the father of artificial intelligence. I would limit it to the father of deep learning. And some 6-7 years ago, Geoffrey Hinton made a famous prediction. When you hear prediction in artificial intelligence, you already know what's going to happen. So he made the prediction 6-7 years ago that AI was going to replace radiologists and we should stop training radiologists. 6-7 years ago, didn't happen. We still have radiologists. We still have actually a shortage of radiologists. If you're wondering about the cartoon in the top left, that was the metaphor he was using for radiologists. Radiologists are running along and haven't noticed that the ground has already disappeared underneath their feet. So the prediction isn't true. Radiologists are still around. But he has a point, and I think this experiment illustrates that very nicely. So some people decided to train pigeons to look at pathology slides. And they actually did the same experiment with radiology images, and the results were similar. So they presented the pigeons with pathology slides, and they had to pick left or right for malignant and benign, and then they would be rewarded. And of course, as you may imagine, at the beginning, the pigeons had a performance of 50% low, so completely random. But after 2 weeks, the pigeons actually got to 80%. Not bad. What's more interesting is if you take the flock of pigeons, so the collective of the pigeons, they got to 99%, to as good as the pathologist. So that's certainly food for thought. And it puts into question what these people actually provide as value. And if you think, oh, that's pathologists and radiologists, I think it's going to happen to all of our jobs. What I personally think is that, and I'll speak about radiologists without offense, because I think it's going to happen to all of us, but we will have to reconsider what is the value professionally that we actually bring to the table. So in radiology, you might think what I'm really good at and what they're paying me a lot of money for is to identify nodules in a lung. Guess what? Pigeons can do it, AI can do it. So what is the real value of a radiologist? And having worked with radiologists all my life, is they have to make sure that the imaging is done right, that the right imaging is done. They have to communicate with the ordering physician. They have to answer questions from the surgeons. And increasingly, they have to communicate with patients. So it shifts your understanding of what you actually bring to the table. And it's something that I would advise all of us to think about for your own job as well, because AI is going to impact all of us, but I think it's actually going to be in a good way. It's going to take some time, of course, because AI makes mistakes. This one is an egregious one, where Google Photos identified images, labeled them, and if you look at the middle row, the lower picture, it identified this picture as gorillas. That's, of course, shameful and embarrassing, but it highlights that AI has bias. It depends, AI's performance depends on what it's trained on, so what data do you use to train the AI, and then also what use cases are you going to apply it in. So if you don't put the right data into the training, and then you apply it to data that wasn't in the training, you're going to get wrong results. Very important to understand what data AI is trained on. And it's also possible to trick the AI. So Google Photos identifies a cat. It identifies guacamole, that's an avocado dip. And some people at MIT 7-8 years ago did an experiment where they, Google Photos identifies a cat correctly, but then they altered the image of the cat in very subtle ways at the pixel level, something that you wouldn't see at the macro level. And they were able to make the AI identify the cat as guacamole. This is called an adversarial example. So you can fool AI as well. But then you can fool humans as well. So I'm not sure whether you see the gorilla in this picture. If you don't see a gorilla, you're in good company, because they showed this picture to a whole bunch of radiologists, and 40% of the radiologists did not see the gorilla. So now it's time to switch to the last topic of my talk, which is ChatGPT. It appeared over the last 6 months or so. Actually, let me ask the audience here, who here has not used ChatGPT? That's surprising. That's really surprising. I would encourage you to start interacting with ChatGPT, in particular because I told you it's going to replace you. So just a joke. Chatbots are not new. AI chatbots are not new. Microsoft introduced Tay about 6-7 years ago. And it was a chatbot that was sitting on Twitter. So it was answering tweets, and it was learning from tweets. And pretty quickly, it started to say pretty shameful things. I fucking hate feminists, Hitler was right, and stuff like that. So Microsoft had to take it down, obviously, because some improvements had to be made, to put it lightly. ChatGPT is a lot better at this. So for example, digital dentistry, I created the first couple of slides of this talk, and I think it did a pretty good job. I showed it to a couple of dentists, and they thought, you know, it's certainly pretty good. And you know, I've certainly started to consider ChatGPT to at least give me a structure for conversations or articles that I want to create. My kid, one of my daughters is in college, and I can tell you that ChatGPT is used a lot by those kids. But ChatGPT also failed spectacularly. My mother is an Austrian painter. She's, I think, 88 or 89, but still creates arts and lives here in Vienna. She has Wikipedia pages, so she has an online presence and her own website, etc. And I asked ChatGPT to create a biography of my mother. To create a biography of Moria Menhardt, I asked ChatGPT, and it came back with Moria Menhardt was a Hungarian writer who lived in the 19th century. Completely wrong. So I decided to help ChatGPT, and I said, do a biography of the Austrian painter Moria Menhardt. This was better because at least it provided the biography of a painter, but the painter was born in a different year. The style of art was different than my mother's. The professor that she studied with was a different professor. So it's wrong. This is what's called hallucinating. And ChatGPT hallucinates, and it does that because it's given a prompt, and then it tries to create something based on that prompt that matches the data it has as best as it can. In this case, because there's not a lot of information about my mother on the internet, it wasn't very good, so the match was not very good. In the case of digital dentistry, there's a lot of information online, so ChatGPT did a pretty good job. So this is the third time for Nerd Alert, so you can go back to your email if you don't want to know about the details. And it's also the third time that I'm bringing Dr. Shannon into the game. So what he did many decades ago, and I want to explain to you a little bit how ChatGPT actually works at its foundation. But what Dr. Shannon did was, he took a book, he selected a first word, which was the word the. He opened the book, looked for the first occurrence of the word the, and then checked what is the word after the word the. And that happened to be head. So then he took the word head, went back to the book, looked for the first occurrence of the word head, and the next word was and. And he continued that, and he came up with a sentence. The head and in frontal attack on an English writer that the character of this point is therefore another method. This is English, but it's nonsensical, of course. But it's surprising, actually, I think, that just by randomly using this algorithm through a book, you can create an English sentence. So let's try to do better. Let's use sequences of forwards, quadruples. We'll start with I continued walking in, and we'll look for the sequence of those forwards in a book. I don't know which book, I don't even remember who did this experiment, but what they came up with, the next word after the first occurrence of I continued walking in was this. So then they continued and used the next forwards, continued walking in this, and looked for the first occurrence of that to determine what the word was going to be. And continuing this, they came up with this sentence from the book. I continued walking in this manner for some time, and I feared the effects of the demon's disappointment. So this is English, and it actually makes sense depending on the context, of course. So I think it's pretty amazing that a simple algorithm like this can create a sentence that makes sense. Now, if you take this a step further, what we've done is we match the four words to the first occurrence of those 4 words and then take the next word. But that might not be statistically correct. It might be a very unusual word, and in other parts of the book, the same 4 words may be matched with another word. So let's do statistics. In this case, 3 words. So let's use had as small, go through the entire book, look at what word appears after that, and count them, do statistics. And then maybe to improve it a little bit, we'll allow some semantic matching. So had is small, let's also allow had a little. And you get to a statistic of what words are most likely to follow those 3 words. And that's pretty much how ChatGPT works. Nerd alert is over. ChatGPT, somebody has called it a stochastic parrot. So if you understand that this is all it does, it takes pretty much the entire internet as their database, so it's huge, but then it uses word matching, prediction of the next word, and that's how it comes up with its answers. So it does not think, it does not reason, it does not self-reflect, it does not create even, because everything that comes out of ChatGPT is already in that database. And I think it's very important to understand that if we think about what ChatGPT could do. And there are people, of course, that predict that the world come to an end, and I will talk about that on a future slide as well. But whenever you hear something like that, remember what the main foundation of ChatGPT is, what it really does at its core. Anyway, let's talk about a couple of topics that may come up. Will ChatGPT have an impact in medicine? And an interesting article that I found recently from the Journal of the American Medical Association, which is titled Comparing Physician and Artificial Intelligence Chatbot Responses to Patient Questions, posted in a public social media forum. So patients ask questions, physicians answer those questions, and let's see what how chatbot responses compare to the physician responses. And the results are actually pretty shocking. So the quality of the chatbot responses was better on average than the physicians. And what's even more important is that the empathy rating of the response of the chatbot was better than that of the medical doctor. So something is going to happen here. I think this technology will find its way into medicine pretty quickly, taking into account all the risks that I already started to mention. And I think even at this conference, there will be some talks or posters about using chatbots in medicine. You've all probably seen computer-generated images. So what I talked about for ChatGPT was predicting text, but the same technology also exists for predicting images or creating images. And here's an example from Midjourney, some Nordic warriors. And I think this is completely amazing that the technology can create an image like that has never ever existed before. It's very realistic and lifeline, and it could have been amazing. This technology, of course, can also be abused. You can ask Midjourney to paint paintings that were never created. You can ask the Pope to wear something that he would never wear. And this creates risks, of course. But faking art is actually not new. Some of you may know this guy, Beltraki, who fooled the art world for decades and created fake paintings of famous painters. So the idea of faking things is not new, just the scale that AI introduces is, of course, amazing. And by the way, Beltraki, I encourage you to look this up. I saw an interview with him after he was released from prison. He's a very funny guy. And then he was asked, so is any of your fake art still around? And he said yes. Is it available for public viewing in museums? And he said, and he's laughing. He said, yes. Do you have any examples? And he says, Albertina. So next time you go to Albertina, try to find it. Similar thing in music, right? In music, AI can generate music by artists that those artists never created. I think AI created finished a Beethoven symphony, if I'm not mistaken. couple of weeks ago, an interesting incident happened. Some anonymous artist, I have to say, some anonymous artist took the voices of two famous popular performers, put them together, and created a new song that didn't exist before. And not only that, the public liked it very much. So it was very popular. The music industry was able to take it down pretty quickly due to copyright infringement, but only because that anonymous artist also included a very short clip of an original song by one of the artists. And the music industry found that and could use it as a reason for copyright infringement and taking it down. But of course, this is going to happen again. And the music industry will have to deal with that. I like what the artist Grimes posted on Twitter. She said, "I'll split 50% of royalties on any successfully AI-generated song that uses my voice." So she considers AI a partner, a collaborator, like a human collaborator, and she just wants her cut of the royalties, and otherwise it's fine. So we'll see what happens. It's going to be very interesting. For those of you who have been around, I'm reminded by this thing which upset the music industry a couple of decades ago. And eventually they sorted it out and new technologies, new business models have emerged. Now, the most important impact of ChatGPT that people consider is work. How is it going to change our work? And what doesn't help is an announcement like this, where the CEO of IBM said he's going to freeze hiring and he's going to replace 8,000 jobs with AI. My personal opinion, I suspect that the reason for the freezing of the hiring was a different one. And I'm very suspect that somebody could actually replace jobs one-to-one with AI. I don't think that's going to happen. I very much like this quote here, where apparently somewhere it says, to replace programmers with AI, I should say ChatGPT can also program. And I've tried it out. So some simple programs it can write. That's true. But to replace programmers with AI, clients will need to accurately describe what they want. So he says, we're safe. Because as many of you probably know, successful software projects are successful if the requirements are defined, the user needs are defined in very much detail. And once that's happened, programming is not so hard. These kinds of transitions have happened before, of course. In the beginning of the 1800s, the hand loom was replaced by the mechanical loom. 12, 14-hour child labor 7 days a week was replaced by mechanical looms. So at the time, a dramatic change. In hindsight, maybe good. Or typists, large armies of typists that are working on content in the past. Now you can sit with a MacBook in a corner and do the same thing. Again, people lost their jobs, and structural transformation was necessary, which was painful. But I would challenge you to find large armies of people that want to go back to typing. So these changes happen. How does this impact dentistry is the question, of course, that you might ask yourself. And this chart is useful to look at that. It looks at how will digital health, AI, etc., impact physicians in different disciplines. And the way to read this chart is if your job involves using a lot of patient-generated data, then you're at the bottom of this chart. If it's more personal interactions, you're at the bottom, at the top of the chart. If the job is repetitive versus something new every other day, that's the horizontal axis. Jobs that will not be impacted very much by digital health and artificial intelligence are in the top left quadrant. So you guys are safe. Finally, a word about risks. So one article I liked was in Time magazine, where the author essentially predicted a scenario where artificial intelligence technology will find a way to connect itself to biotechnology, to robots, and so on. And it will determine that in order for the planet to survive, you have to eliminate those elements that destroy the planet. So the best course of action is to kill all humans. So his prediction was, AI is coming on the planet, we will all die. I'm sure many science fiction books have been written around this topic, and many others will be created. And it's maybe a little extreme, but some serious scientists and players in industry have similar sentiments. So Geoffrey Hinton, who I introduced before as the father of deep learning, worked for Google many years, recently left Google, and he warns of the dangers along the lines of what was just described. And you're also familiar probably with an open letter that Elon Musk, Steve Wozniak, the founder of Apple, and others have signed where they ask to freeze AI development for some time until we figure it out. I personally don't think the freezing will work, and I think a lot of people agree with me. One easy argument is, yes, but China. So if the West freezes AI development, China will not freeze it. But I think a more subtle argument is more important. And this is a document that was leaked by somebody in Google. And it's actually a very interesting document. If you're interested, look it up and read it. The author addresses the topic of should Google keep its AI proprietary? Should it protect it from other people from using it? Just like OpenAI keeps its technology proprietary as well. And so the memo is titled, "We Have No Moat," which essentially means we have no defenses. So even though we may think we can protect the technology and stay ahead of the game, this is actually not true. And then it proceeds to talk about Facebook, who has a large language model like ChatGPT, which is called Llama. Facebook in February apparently released Llama, which is the structure of a neural network that is the foundation of their chatbot. But it only released the structure, not the weights. Remember the weights that I was talking about earlier that are trained? It didn't release the weights. So researchers could have used that and trained it and so on. But then somebody from within Facebook actually leaked the weights as well. So now Facebook's chatbot was out in the open. Out in the open in today's day and age means that there are thousands of researchers, hobbyists, hackers, scientists that get a hold of it. And now in a massively parallel scale, people are continuing to develop on top of that. And what you can see here at the left is Llama, which was the original Facebook thing. And improvements to Llama by the community happened very quickly. In the course of weeks, it improved performance significantly, approaching what Google has, it's called BARD, and what ChatGPT or OpenAI has, which is proprietary. So keeping things proprietary makes no sense because the community is racing behind the big players. And what it's doing is not only improving the performance, they've also found tricks to reduce the size of the network that's necessary, tricks to improve the training that's necessary. And in the article, it actually says that with a big laptop, you can now do what OpenAI does with thousands and thousands of computers. So this, is, to me, is the reason why freezing makes no sense, because the cat is out of the bag. Things will happen. So in terms of the risks, what do we need to do? In the US, Congress is having discussions about introducing regulation. And I think that's the right thing to do, because if you think about dangerous technologies like nuclear arms, atomic energy, or medical devices for that matter, what we've done is to put guardrails and regulations around those systems, and we fared pretty well with that. The EU actually created a draft for AI regulations about 2 years ago. At least that's what, as much as I know. At the time, I worked for a large medical device company. We looked at those regulations in much detail in order to determine how much burden it was going to add to developing AI medical devices, because now you have to follow the medical device regulations and also the AI regulations. And unfortunately, what we found is that there's a whole bunch of overlap, but subtle differences between those regulations. So it's going to be more expensive to develop AI medical devices. But it's probably necessary in order to follow the manage the risks of AI. Interesting article by Tim O'Reilly, who says you can't regulate what you don't understand, but fundamentally he supports regulation. And the challenge, of course, with regulation is the draft for the EU AI regulations were released 2 years ago. They are not law yet. So let's say they become law in 2 years. And in 2 years, AI will have developed in a direction that we can't predict yet. So regulations will always be behind. And therefore, the regulations have to be at a very abstract level. Some of the regulations that we can envision are disclosure, just being transparent about what you're doing. For example, remember the monkey picture or the fail of Google Images. Publish what is the data cohort that you're training your AI on. Identify what are the use cases you are looking after. So those kinds of regulations should be in place and will be put in place. Brings me to the end of my talk, digitalization, AI, and the metaverse. We'll talk about the metaverse another time. I still think it's a very exciting development. But I want to leave you with this as a last slide, which is, if you recognize it, the Gutenberg printing press. And the Gutenberg printing press, I think, created a change in technology, society, information exchange, like ChatGPT is bringing to us in 2022, 2023. I think the two are actually comparable in terms of the magnitude of the change and in terms of the impact it could have on work and society. The Gutenberg printing press, the first book was printed in 1350, I believe, and by the end of the century, 10 million books had been printed, and 1,000 print shops had been created in Europe. So it was very, very rapid, and the change was amazing. Before that, books were hand-copied and therefore very expensive as a Tesla today. So books were certainly not something that everybody could buy. Now, all of a sudden, books were available to people. Literacy went up. Before, you didn't have to read because there were no books. Now, literacy went up. Information exchange started. Science got a boost. And Reformation also wouldn't have been possible without the printing press. So looking back, of course, when the printing press was invented, some people lost their jobs. Calligraphers, people that copied books, etc. But the impact was amazing. And if I look back and think about the printing press, was it a good idea? Is it something that we should have stopped, that we should have frozen? I don't think so. Books were a good thing. And what I think and hope is that after addressing risk, etc., that 10 years from now, we will look back to 2022 and 2023 and the introduction of chatbots and AI of the scale that we have, and we will think this was a good thing for humanity. Thank you very much.